Good morning. I'm Jeff Hammond, Executive Director at International Ground Source Heat Pump Association, or better known as IGSHPA by most of us. Welcome to the August Town Hall. We have a record here of number of presenters. Terry Proffer is joining us. This will be his third presentation, so we're thrilled to have Terry and thank him for his support of IGSHPA. Before we get started with Terry's presentation, I have just a few notes that I'll go through some slides and update everyone on the latest happenings at IGSHPA. So thank you for joining us for the August Town Hall. In the latest IGSHPA news, you've seen this slide, I'm sure, but we're taking submissions for 2024 Town Hall and Dig Deeper webinars. If you have a topic that you'd like to discuss and bring it to members, just go to igshpa.org, click on the events training menu at the top, and you'll find a form here to submit your abstract. Likewise, on that same page, starting this year, we now have sponsorships available for the Town Hall and Dig Deeper webinars. So if you'd like to get your name out there, these are recorded, as you know. So your logo will be on that webinar for as long as it's online, I guess is the best way to say that. Updates on the conference in December. It's December 5th through the 7th in Las Vegas. We have all the information at igshpa.org. You can register now. If you haven't set up an exhibitor booth, about a third of those are already filled. So if you're looking to exhibit, you want to make sure you get that in as soon as possible. Same with sponsorships and advertising opportunities. The sponsorships are, I'll go through here in just a second. They're mostly filled up. And if you've been watching your inbox for email, you'll notice some special deals on advertising opportunities with both the conference program, and we're restarting the Geo Outlook magazine. So you have an opportunity to advertise in both with some special pricing. Our conference sponsors, as I mentioned, are filling up. We're thankful for all the sponsors we have so far. As you can see from the screen, we have quite a number of sponsors, and we certainly couldn't do this conference without our sponsors. We really appreciate their support. There is one bronze sponsor, one silver, and one diamond sponsorship available. So act quickly if you're interested. These are the exhibitors we have so far. As I mentioned, about a third of the hall is already filled, but there are quite a few booths left. They're 10 by 10, 10 by 20, or 20 by 20. So you can certainly combine these booths if you are looking for more space. And the location here is right inside the doors. There's actually a set of doors over here to the right side where my cursor is, and there's another set on this side. The NGWA exhibitors are all in this area. So as the doors open at 10 o'clock on Wednesday, local time, you'll have traffic right through that doorway. For the program guide itself, as I mentioned, we still have ads available, but check out igshpa.org for details. Or if you'd like to know a little bit more about the special opportunity to advertise both in the program guide and Geo Outlook, the next edition will come out in September. Contact us and we'll be happy to give you that information. The conference agenda is now online at igshpa.org. It's pretty exciting this year. It's been exciting the last 2 years, but this year we have even more workshops and certainly a lot more tracks. We have 11 tracks, 49 workshops, our annual general meeting, as well as the leadership address. Plus we have a welcome reception in conjunction with NGWA, and we have quite a few joint workshops with NGWA on Tuesday. So I think you'll enjoy the conference coming up in December. We're really excited to have a keynote speaker from the Department of Energy. Alejandro Moreno is the acting assistant secretary for energy efficiency and renewable energy at the U.S. Department of Energy. So I think he'll be a great keynote to give us an update on what's happening at DOE and more specifically in EERE. He works with the Geothermal Technologies Office and will be able to give us an update on what's happening in the world of DOE. The research conference is now set up for 2024, and we've already started taking abstracts. Those will be received through September 18th. There's a committee that's reviewing those abstracts, and we'll be notifying authors starting October 1st Once those authors are notified, then they'll be able to submit their papers for approval. So more details again at IGSHPA.org for that research conference, and it's in Montreal in May, end of May 2024. CEUs for your IGSHPA certification, just like always, if you'll send a chat message with your name and email, then we'll give you credit for these town halls and dig deepers. So just send your email and your name in the chat, and we'll keep track of those. We do have a new feature. If you happen to be watching this video online after the town hall is complete, you can get credit for watching it. And how that happens is you use the code that you see towards the bottom here. If you're watching it online, if you're joining live, you don't need this code. Just simply submit your name and email like always. But if you happen to be watching this after the presentation, that code will be the validation for receiving those CEUs. Just a little housekeeping here. We'll be taking questions for Terry after the presentation. If you would, please put your question in chat, and I'll read those once Terry's complete. If we do run a little bit long and we don't get to all of your questions, we'll get back with you as soon as possible and answer those questions. Out of courtesy, please mute your microphone unless you're speaking. And as I mentioned earlier, this session is recorded, so you'll be able to view it on the IGSHPA website. If you go to IGSHPA.org, at the very top, you'll find a YouTube icon. Click on that YouTube icon, and usually in a couple of days, it's been downloaded and it will be available on the website. Just a quick disclaimer and conflict of interest statement, and we'll be ready to go. So the upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any product or services by IGSHPA or its members. IGSHPA town halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. So now let me introduce our speaker. As I mentioned, our third time town hall speaker, Terry Proffer, has been involved in the GSHP industry since 1992. After a career as a petroleum geologist starting in 1979, after graduating with a geology degree from Sul-Ross State University in Alpine, Texas. He has designed closed loop systems for small residential applications to facilities exceeding 350,000 square feet of conditioned space, including various commercial, institutional, and military projects. Terry is the manager for Major Geothermal of Wheat Ridge, Colorado, a firm specializing in the design of closed loop ground heat exchangers, peer review, installation, quality assurance, functional testing, and GSHP system forensics. So we're thrilled to have Terry. Let me switch over to Terry's presentation, and we'll get going.
Thank you,
All
Jeff.
right.
I
All
appreciate
yours,
it.
Terry. Thank you.
You bet. Thank you. Appreciate the introduction. Just a few words before we start. We're not naming this school because it went through litigation for construction defect litigation, and wasn't anyone did anything intentional. It was to hurt this system. There was just a lot of moving parts. A lot of people just didn't know what they needed to know. Given that, let's move forward with the next slide. And the next, we've already gone through the disclaimers. So just a real quick overview. This school was completed in 2006, about 200,000 square foot of conditioned space, originally with a ground source heat pump system, and was one of the largest high schools in the state of Colorado, by the way. There's 169 total heat pumps, and the original loop field had 200 boreholes, 400 foot deep. Next slide. So just to give you a perspective, we've got a little bit of a drone flight site. So if Jeff, you want to click on that, and hopefully it'll come up on the screen to give everyone a perspective on this thing. This was towards the latter part of the new loop field installation. The whole area behind the snow fence or barrier is the area we had to deal with to put in the new ground loop. Now it looks like there's a lot of property available to put in a loop field, but there is so much infrastructure in the subsurface. We actually had a lot of challenges on designing the field, how we pre-designed it to a new depth and that sort of thing. It was actually quite the challenge. So a lot of teamwork between civil, structural, architectural contractors involved. It was a mess. At one time, we had as many as 3 drill rigs on site for this project. Can America Drilling here in Colorado did all of the drilling. Right behind the drill rig there is actually the mechanical room area. We just now it's out of the view, but you can see this is a pretty good size site. All right, so we can dispense with that now. All right, next slide, please. So we were engaged in 2016. The client had problems with the ground source heat pump system. Original design team and mechanical contractors were struggling to figure out what was going on. We got on site. We quickly determined there was more than a lot of issues than with just the ground loop. A lot of interior issues. We actually asked for help. One engineering firm local to the area started in, and then we brought in BDK Engineering. Beth's kind of specialized in a lot of forensics, so she was really useful to bring on board to help us sort things out. And the more we sorted things out, the more we found. So this was a long process going up through last year. Next slide, please. So we brought in, like I say, other engineering assets as necessary. Tallinn Mechanical was selected not only as lead mechanical contractor, but also as to be general contractor for this project. Client rep was Diversified Consulting Services. They were great at keeping things organized and keeping the client updated. We did not do anything to move forward on the project without the client being involved. So a lot of times we had to sit down, explain all the technical stuff. The client was great, school district superintendent, and he kept the school board engaged. So no one was wondering what we were doing in the background. And what was interesting, we were able to do all this without shutting the school down at any time. Next slide, please. So what were the initial issues? Well, the big deal was heat pumps were locking out all the time. And of course, when did they lock out? When it was really cold or really hot. So the facilities people thought the water from the ground loop was too cold in the winter and too hot in the summer. Their operating costs were pretty substantial, they felt. They also said, most of the loop field couldn't hold pressure, so we suspected leaks. They also had a history of internal piping failures. We noted control conflicts all over the place, and the reliability of the system was just in the toilet. It was very, very poor. Next, please. So by the time we were involved, the client had one thought about ground source heat pump technology, and they did not like the train wreck at their school. They were convinced they would never want to do another ground source heat pump system. It was just not proven. Next slide, please. So we had an initial meeting after our initial evaluation. Again, the key school personnel were convinced the heat pump technology was, not worth it. They wanted to, they asked what would be the least expensive thing to do. And I was honest. I said, we could put in a conventional boiler and chiller system and be done with it. But we did remind the client that their administration headquarters, which had been in operation for over 10 years at that time, was entirely conditioned by ground source heat pump system. Well, no one realized that. And that just goes back to that old adage, if everything's working great, no one pays attention. So this was one of those situations. So we also explained and got the school district in touch with other schools in not just Colorado, but elsewhere, that ground source heat pump systems were pretty common with schools these days. So they decided to go back and say, okay, can we resolve the issues and make this an operational ground source heat pump system? We said yes, but it's probably not going to be cheap. So they did elect to go. We did initial budgeting. They decided to move forward. Next slide. So first thing we did after our initial visit, we wanted to make sure the loop field, had enough capacity. So we took the original cooling and heating loads from the original firm that designed the system. BDK ran a reality check on the loads, and both we had the TC test results from the original design, and we believe the loop field had more than enough capacity to support school. In fact, when we measured entering water temperatures, in the winter, we were always well above 40 degrees and never over 80 degrees. And those of you that are familiar with the industry, that's pretty good stuff for ground source heat pump. Excuse me. What we did find, though, were a lot of installation conflicts and of course controls conflicts, and we were suspicious of contamination in the field. Next, please. So when we started poking around in the 160 some odd heat pumps, we said, well, when these things lock out, are all of them locking out or just a few? Well, they finally realized that no, it wasn't all of them. It was certain parts of the school. So first thing we checked was, were the control boards set for extended range? What that means is heat pumps are usually shipped to limit what entering water temperature they'll deal with. So if someone forgot to put antifreeze in the system, they won't freeze up and burst a heat exchanger. So everything was set for extended range. That was good. So, but they were assuming that it was low entering water temperatures in the winter based on control board errors. Well, that was a misinterpretation, as we learned. Next slide, please. The ones that were really problematic, the strainers were just loaded with gunk. Well, what it was, that restricted the low water flow, and the control board codes were saying insufficient temperature. Well, it wasn't temperature, it was low flow. So that was what was causing these heat pumps to lock out. And to prove it, we cleaned out a few of them, fired up the heat pumps, measured entering water temperature in the low 40s. They were good to go. And it's just no one had been maintaining these. Initially, at startup, all the strainers had been cleaned out, but you'll understand why it was. It continued to have a problem later on. And incidentally, we could tell which heat pumps were low on flow just by the sound. When the compressor was just jackhammering and just really noisy, we knew they had low water flow. Next, please. So what it turned out, the clogged strainers were just part of the problem. First thing we did was start looking at the material in the strainers, and we noted not just typical things like iron and copper shavings. We had, in some cases, pebble-sized stones, so that would have come from the dirt. But we found a lot of PVC plastic, and that really bothered us. Where's the PVC plastic coming from? We also realized that pumps were cavitating a lot of air in the system, even though they had a water makeup valve on the system. We just assumed before getting the drawings We had 10 header pairs servicing the 200 bores with an equal number of bores per pair. We found that a lot of the header pairs were not maintaining pressure. The central circulation pumps seem to be running at a high speed all the time, and found more and more conflicts the more we dug in. Next, please. So another engineering firm, ME Engineers, local to the area, they were also brought in. They had actually been brought in earlier, and they were the ones that actually brought us in for the ground loop side. But they found multiple high spots in the piping with no vents for air removal. So a lot of the heat pumps downstream from those high piping areas, once the air vents were added, they started working properly. So, you know, the more we dug, the more we found, the more we resolved. Next, please. So we finally got the as-built, and I was shocked. We had one header pair with as few as 9 holes, and one header pair with as many as 40 holes on the system. We really understood then they probably had never purged the system of air correctly, and in fact later we found that was exactly the case. In fact, when it was finally purged correctly, we made up like 2,000 or 3,000 gallons of water, which helped improve the system immensely. Next, please. So we identified 2 of the 8, I'm sorry, that should be 2 of the 10 header pairs, excuse the typo there, would not maintain pressure. And we realized that they could be shut down. The field would work just fine. It did. The 40 bore header pair, we calculated what the purge rate would have to be based on the pipe size in the ground loop and the reducing manifold, and they would have needed 473 gallons per minute at over 100 feet of head to clean that thing out. And the report said the contractor purged at 165 GPM. And he said, "Oh yeah, it's clean of air." No, it wasn't. So we also found all kinds of contamination. Next slide, please. So this is an example of calculation I did for the forensics and to explain to the school board why that was such an issue. So we're not going to go into all the details of how to design a reducing manifold, but the one on top is for the 40 hole part of the field, requiring 472.8 gallons per minute. Had they at least designed the reducing manifold correctly, that would have dropped to 362 gallons per minute. So that made a big difference. Next slide, please. So we brought in what I consider an industrial strength trailer mounted purge rig, big 4-cylinder turbocharged diesel engine to run the pump. We could do well over 500 GPM at 200 feet of head with this thing. As we found out later, we couldn't get all that flow rate all the time due to a lot of the contamination in the field. But we did install a large settling tank before the water was run through a filtration plant, which is the photo on the right side of the slide. Next. This is after several passes of purging. It's hard to get a perspective on the top photo at the bottom of the tank of all the grit and crud that's in it, but it was a lot, and it wasn't just dirt. There's a lot of internal piping and PVC pipe shavings that were in there. And I apologize for the photography. I was the one that did the photos, and I'm not a real good photographer, but trust me, that filter was loaded with a lot of garbage in the bottom. Next slide, please. So one of the things that we were involved with over several years was we continued to lose header pairs. tried to identify where the leaks were at. We looked at the cost of getting in and excavating and trying to identify things. We tried on several occasions. It was a challenge. Further during forensics and the litigation stage, we found that everything was bottom fed on the ground loop. One guy did the drilling, another guy did the headering, someone else did this, or someone else did that. There was no communication between any of these contractors. So by the time we put the new ground loop field online, only 2 of the 10 header pairs were still operational for 40 borers to service 200,000 square foot school. So we were just in time, as it were. Next slide, please. So one of the things we found in the mechanical room was there was no purge points. So that had to be added in so we could isolate individual header pairs and manage the purging effort. The original contractor said they purged it from outside. They had a vault out there. Later on, when we poked around and excavated, we found no evidence of that. And there was no isolation valving or other infrastructure that you would normally see for a closed loop ground source heat pump system. Next slide, please. The controls were another matter altogether. So one of the retrofits that was done before we got involved was they put in boiler assist because it thought the ground loop was too cold. So the controls contractor, no one gave the guy any input. He ran the boiler to keep the building loop and the ground loop at 70 degrees Fahrenheit. And so the school, as you might expect, had a huge natural gas bill that was unnecessary. We also noticed even the nomenclature and labeling on the building automation system was incorrect and confusing. They were supposed to be recording trend data indefinitely, and they did have some good trend data they were collecting, like loop temperatures, that sort of thing, but they were dumping it every 2 weeks. So we had no long-term record keeping of what was going on. And the more we dug on the controls, the more we found to be problematic. Next, please. And then we found a big gorilla in the room. As I noted earlier, we'd found PVC pipe shavings in the strainers. So I was wondering where this was coming from. Of course, all the piping was covered with insulation and all that. What we found was all of the main primary piping throughout the building was PVC pipe. And we asked, why was this done? Well, it was value engineered because they were over budget. And so they shifted to PVC from hydronic steel. And they'd also hard mounted all the PVC pipe. And that was a big part of the problem, as you're about to find out here. Next slide, please. So we started digging into the PVC issue. I didn't know anything about it, but it just seemed something was wrong here. We actually found a consulting group that specialized in this, found out it was a common problem. First off, PVC and CPVC do not get along long-term with propylene glycol in water. So this had propylene glycol for antifreeze in the system. But what happens with propylene glycol and PVC pipe is that over time, it creates environmental stress cracking from within. So you have no warning when it fails. Another issue is if a heat pump water to refrigerant heat exchanger fails and gets the lubricant oils in the water, that accelerates damage to the pipe even faster. In fact, there are like papers out there on the internet about how bad PVC piping systems have failed because of that. The other thing we found was PVC pipe will expand and contract up to 3/8 of an inch for every 100 feet of pipe length for every 10-degree change in temperature. And where the failure's been to date, right at long piping distances at elbows where everything was hard mounted. So something had to give, and that was a PVC pipe. And we did not get a chance to test the failed pieces for ESC at the time, but we strongly suspected that was part of the issue as well. Next slide, please. So the utility bills were really expensive, and the client was thinking, well, that's because of these heat pumps, you know, those nasty things, they're just draining a lot of power. Well, we looked at their scheduling. They did have the heat pump staggered at startup in the morning, so they weren't getting a big demand charge. They did have some really high power consumption though. So we did test a random sample of the heat pumps, standard IGSHPA startup and manufacturer procedure where you measure the temperature and pressure differentials in and out of the heat pumps, voltage and amperage. And we calculated their capacities and efficiencies, and they were all found to be really healthy. But they did have a big power bill, and they had super efficient lighting, and we're thinking maybe there's something in the background going on. Well, we found it. Next slide. Redundant 100 horsepower circulation pumps. They were using these to drive water through the building and the loop field. It was supposed to be a decoupled system with a proportioning valve to direct flow between the loop field and the building as necessary. And that proportioning valve was hunting all the time. It was very inefficient, and it was created its own problems elsewhere. The VFD was installed, but it had never been set or could be tuned. So this thing was running 24 hours a day, 365 days a year at 100% load. I can't remember what the power consumption was, but it was 460 volt 3-phase, and it did suck a lot of power. Next, please. So what did we do to redesign the system? Well, first thing we looked at was redesigning the loop field because we continued to lose header pairs. As noted earlier, we didn't have as much area as we thought to work with. So we came up, before running a TC test, we redesigned the field to 600-foot depth with 1.5-inch U-bends, trying to reduce the pressure drop. We did run a new TC test. We were able to finally reduce the field size down to 80 bores of 600 foot. And so we had 8 header pairs servicing 10 boreholes each. Next slide, please. So we looked at running all the new header pairs into the mechanical room. And because we had to go underneath the service road and a lot of infrastructure, this is one of those cases where a vault resolved a lot of issues and actually reduced the installation cost. So we have a central vault, kind of the lower central part of the slide there, servicing 8 header pairs. Attaboy, thanks. Next slide, please. So again, initially on the surface, it looked like we had a lot of open area, but we had so much subsurface infrastructure piled into the available area where we were trying to put the field in. We had a lot of disciplines helping us out to keep us out of trouble. In one case, we had a large gas pipeline going through the property that we couldn't find, and it had to be potholed to confirm where it was at. Next, please. So we finally got moving. Again, we had up to 3 drill rigs at one time on the project to get things moving. All the drilling was done with mud rotary, so to avoid turning the entire site into a lake of mud, the contractor used mud recycling devices. I know it looks like a bit of a mess on the lower left side there, but believe me, it would have been a lot worse without the mud recycling plants. Next slide, please. Headering was a challenge. We ran into different soils of different hardness consistencies. We did bed all of the header pairs with spoils from the excavation. That saved a lot of money, and it actually worked out very well. We ran into everything from soft, silty sand to sandstone that it was friable, meaning you could break it apart with a hammer real easy, or in some cases even with your hand. But it was interesting. We ran into a lot of different situations on the project. Next slide, please. We were very concerned that we needed to have really accurate data on where everything was located. So all of the borehole locations were shot with GPS coordinates, and radio frequency ID beacons were put on over every borehole and every change in direction on the header pairs. And that was logged in with each discrete RFID beacon. And that log is kept permanently with the client. So if they have to dig up something for whatever reason, they can easily locate these things. So in addition to tracer wire and warning tape, we have RFID beacons installed to help protect the field. Next, please. So here's a picture, a couple of photos of the vault. I personally don't like vaults because I don't like getting in them, but we did try to do this right. It's an HDPE plug and play vault. We paid attention to the OSHA requirements for a confined space, 2 points for access and getting out of the vault. There's lighting, ventilation, and a sump pump. We also have an alarm in there on the sump pump. Should that thing activate, it will send a signal to the BAS system saying that we have a problem. Next slide, please. The engineers on the project, BDK and others, got together with the controls contractor, tried to simplify the controls. Another thing that we did was instead of a portioning valve to decouple the ground loop, we put separate injection pumps to inject into the building loop, controlled by water temperature on the building loop, and then a new centralized pump system with VFD controlled by pressure differential, typical. That resolved a lot of the hunting issues. Well, we eliminated the proportioning valve, so that problem went away, thank God. And it really reduced the operating costs. We also got the boiler backup. It was there, so why not keep it there for belt suspenders? But it does not come on at all now. In fact, we had to write an exercise code into to keep the boiler backup system fresh in case it should ever be needed. Next, please. Because of the cost and time it takes to replace all the internal piping, the school elected to let's do the PVC piping replacement in stages as circumstance and budget permits. So that's going to be an ongoing situation. The filtration plant that was built for the purging was put in the mechanical room, but now it's cleaned out a lot of the field, or all the contaminants, or most of the contaminants, and they rarely have to change filters anymore. We also went over maintenance schedules and diagnostic procedures with facility staff. They're not afraid of heat pumps anymore. In fact, they rarely call an outside contractor because they can deal with it all themselves. Even if they have to replace a compressor, these guys are really good, and they understand now that the heat pumps are not some unobtainium thing that we taught them how to understand the IOM manuals and how to diagnose, and they're good to go. In fact, I wish we could hire some of these guys with our company. They're that good. Next, please. So the current status is the system's reliable, working very well now. They are in progress, like say, in different stages to replace the PVC piping with conventional steel. The decoupled pumping is working the way should be now, and power consumption has really been reduced. In fact, because of the load sharing capabilities, the injection pump rarely runs now. Most of the time the building is load sharing between heat pumps. Of real good use is the controls system now have permanent trending of key metrics. So we can actually go back from the day this was changed and look at how the system's been performing. Maintenance staff are trained. And best of all, the client, i.e. the school board, they realize, it's like any other mechanical system. If it's done right, it works. Ground source heat pumps are no different. Next, please. So what lessons did we learn? Well, a lot of the design and installation operation issues could have been avoided had they had the design team engaged someone with experience to oversee what they were doing and give them a little input. We could have, for example, instead of a 40-hole header pair and a 9-hole header pair, we could have made everything equal. That would have been simplify for balance, test and balance. One of the big problems we found was everything tried to be bottom fed, where they had one guy drilling the original field, someone else doing the headering. By the way, we found out that headering crew had never worked in cold weather, and it was most of their people had never welded HDPE pipe, so there was no oversight on that. In fact, there was almost no contract administration during the installation of the loop field. The as-builts were very poor, as we found out. Not a lot of good data on pressure testing to confirm things. Very poor communication between GC and all the subs. A lot of the contamination issues from the ground loop side could have been avoided with good pipe handling. We actually found during purging that everyone was blaming the ground loops. Well, we'd interviewed the driller, and they were actually the strongest part of the installation team, but they were saying a lot of the contaminant was from the ground loop. Well, it was, but it was from the headering crew, and we knew that to be a fact because we recovered stones, not pebbles, stones in the purging that were over 1.25 inches in diameter that wouldn't have come from the ground loop installation. So we did recover some photos, and it showed header piping being dragged through the dirt, and no one was cleaning it out, we suspect. So anyways, pumping configuration could have been simplified for greater energy efficiency. They should have never used the PVC pipe. That should have been that value engineering effort should have been denied. Control sequence of operation could have been improved with the designer working with the controls contractor. The controls contractor said they never heard from the designer, and they were on their own. They did not understand what they were doing. And the client should have been provided with better maintenance and operational input from the design team. And I believe that's it. Appreciate it.
All right, thanks, Terry. Appreciate that great presentation. I hope you didn't have music during your presentation. I'm getting music on my side.
I didn't hear anything.
Oh, okay. Well, that's good then. We do have some questions already. Let me take a look here at our chat. First one actually is a comment from Kevin. My first reaction is anger with all the parties involved with design and construction, especially the design engineer, school system professionals, and construction team. What a train wreck. GeoExchange Industries know better than the knowledge of the professionals involved and the depth of the private sector involved and their ability to support the industry. Good presentation. Have to cut out early. Any comments on that, Terry? Or
Yeah. I really you know, I was kind of, because I make my living in this industry, I was pretty offended the more I found, but then I realized we really don't have good training programs. And we don't have a lot of experience that's being shared. No one intentionally tried to make a bad design or installation. Folks just didn't understand what they didn't know. They didn't realize the importance of, for example, of site visits to make sure your system's going in correctly. And that's why, like we were talking before the presentation, Jeff, I think the future of our industry is better training. And that's why I'm so engaged with IGSHPA and support of the new IGSHPA. I know it's a long road. We've got to overcome a lot of hurdles. For one thing, all of the people on the training committee are volunteers right now. So we're trying to balance input versus, making a living. So it's, but the reason I like doing these presentations is I'm sharing a little bit from what I've learned and what not to do. And I would encourage the rest of, I know we've got a lot of gray haired geo junkies on this webinar. I hope they will also think about maybe putting together PowerPoints on some of the situations they've come into so we can all learn from, because I think that is the future of our industry.
Completely agree. And I appreciate you being willing to share all your experience with us. Pete has a question. Why was PVC being replaced with metal? Why not HDPE?
That was considered, but it was flame and smoke spread concern, safety issues. By the way, we found that the PVC pipe had a safety issue. If there was a fire, the PVC pipe by itself probably won't burn, but if it gets in a blaze, it creates hydrogen chloride gas, which can, result in hydrochloric acid with moisture. So it's pretty dangerous stuff in this thing. Actually, we were also considering propylene. What's the like Aquatherm product or equivalent? But they elected to go back to steel as they replace the pipe.
Okay, excellent question there. And Elizabeth made that same comment because of pipe penetrations through the firewalls.
Yes.
Other questions for Terry? We have plenty of time. While we're waiting for some additional questions in the chat, I do have a question for you, Terry. What is your recommendation if you find a job with propylene glycol and PVC piping in the interior? I noticed in your presentation you mentioned that they're replacing that on a schedule. Is there a time frame that you recommend, or do they wait until they start to see some issues? Or what are your thoughts on a job that is already piped with PVC and uses propylene glycol?
Well, they're looking at the parts of the building that have had the highest rates of failure. And those are usually where the PVC pipe has had the longest pipe runs, where they've had the greatest expansion and contraction. And then they're trying to balance that with, what part of the school do you isolate? This is an operational school. So there's a lot going into their scheduling. And of course, they're balancing that with budget, as budget permits. So it's kind of a moving target. And Tallinn Mechanical is working with the school district, and they are making progress on it. I would imagine in the next year or two, they'll probably get that all fixed.
Okay, good to know. Johnny has a question here, and he congratulates you on a great presentation and thanks you for sharing. Can you confirm that it was the most cost effective to drill an entirely new bore field and lateral piping / vault accordingly, rather than simply re-excavating and fixing the existing lateral piping? Or were there other concerns in regard to contamination pushed into pre-existing bore field that could not be properly flushed? In the end, is any of the prior bore field in service, or has it been fully abandoned?
Good question. We did consider going back in and re-excavating, but with all of the conflicts, and we did try to excavate on some of the header pairs. For example, we couldn't find where a lot of the header piping was going. The tracer wire had failed on a lot of these. The other problem was when we started trying to follow the header piping with the excavator, it was not where the as-built said it was. And then we ran into infrastructure conflicts where we would have to rip out or go through other piping that not related to the ground source. So it was determined, this was a losing proposition for the cost. When we started looking at all the cost to excavate the entire loop field, it was actually less expensive to put in a new field. We did not want to go there, but we had to. And in the state of Colorado, we could not abandon the existing loop field. So it was purged of all propylene glycol solution and left with pure water in it. The reason being the state of Colorado, and we had a big conversation with the state Division of Water Resources, they had this rule said all the ground loop piping had to be filled with concrete. Well, as you can imagine, when we got that costed out, and all the concrete companies said, we can't guarantee we can do that entirely. We went back with Division of Water Resources and said, what you're asking for is not realistic. So what we're calling that old loop field now is our auxiliary loop field. So it's filled with water. All the propylene glycol charged water has been taken out of it. We reused it actually. And so it's still there, but all isolated and blocked off. It's our auxiliary loop field.
Optimistic way to look at it, I guess.
Yes.
Bill asks to confirm that the original loop field was totally abandoned and then replaced with 1.5 U-bend deeper bores. So he's asking about the bore depth and the pipe diameter.
Mm-hmm. Yeah, we went to the 1.5 pipe. It gave us a slight reduction in pressure drop for the flow rates required. If we could have put in 2-inch, the drillers probably would have shot me, but I would have liked to have gone in with 2-inch pipe, but we couldn't do that. So the reason we went to 600-foot depth was to get the capacity out of the field for the loads. We just didn't have enough area to go with shallower holes. We were forced into that by the limited area.
Makes sense. Andy has a comment. 100% agree with Terry on training. The UK has previously had cash going in at the top end of the process to clients for incentives with poor results when cash going in at the start / bottom for supportive designers, contractors, installers, etc. results in a better system and better practices, better efficiencies, and then reducing first cost. Incentivized training programs would be a better use of some of these public funds. Any comments on that?
Yeah, I'd actually like to see not just, required levels of training and experience for designers and installers, but I would like to see if, like, we've got these federal incentives now for the United States, I would like to see some validation requirements to earn that. That is, proof that the ground source heat pump system is working as intended for getting those tax incentives, whether it's residential or commercial. I think that, we're already seeing it as an industry. We're seeing a lot of systems going in, again, people that they're not intentionally trying to install a problematic system. They just don't know what they need to know. And I would wish we had some teeth in our incentives programs, whether it's from a utility, a state tax incentive or a federal tax incentive. But what do I know?
I hope some of those organizations take you up on that advice, Terry.
Yes.
Michael has a question. Do you know if there's an issue with PVC and alcohols as the antifreeze?
The special consultant we work with said that, yeah, there are, and I'm not a plastic chemical guy, but there are some issues with some alcohols and PVC pipe, from what I'm told. one of the things I was told was that some alcohols, depending on the type of glue used on PVC pipe, the alcohol can become very aggressive to it. So again, you need to do your own due diligence on that. If you're going to use PVC pipe and alcohol as an antifreeze, but I would be careful with that.
Makes sense. Manuel has a question about the 2-inch loops. Would that have lowered the 600-foot depth? I guess he's asking if it would have required less borehole with 2-inch Q-bins.
Possibly. We actually ran simulations with 2-inch. It didn't reduce the pipe lengths that much. What it did though was really reduce the pressure drop, and we could still maintain our Reynolds number for turbulence. So it was a consideration, but after talking with the drillers, I was threatened with to be buried in one of the header pits, so didn't want to go there.
Makes sense. All right. Jim has a question about fusion. Proper fusing mandatory, not just because of loss of pressure fluid / fluid, but that fluid will pollute the aquifers involved. Wouldn't that be at least as important to our trade as to the regulators?
I totally agree. The nice thing though with using food grade propylene glycol, even if you got a leak, it degenerates really fast. And it's non-toxic to begin with. I mean, it's nothing you want to drink all the time, but propylene glycol is used in your toothpaste. It's in a milkshake from a fast food joint. I mean, you look at any processed food from a supermarket, about half the stuff you see, if you look on the ingredients, you're going to see some amount of propylene glycol. That being said, we were very anal about making sure all the fusion was done correctly out in the field. We did actually catch one of the headering crew. He didn't realize it was a new guy. No one's fault. He just wasn't paying attention. But the fusion iron, I noticed he was trying to make socket welds and he was really fighting with it. And I checked it with an infrared gun. Well, his heater was off. So, and it was almost cold. So anyways, that's also another point in favor of contract administration. If you're involved with the design of these things, you need to get your tail out there and make sure things are going in correctly. Right now, I'm delinquent on a lot of my projects because I've been so swamped. So I'm just as guilty as everyone else of not getting out in the field as much as I should. Thank God we've got some good contractors out there right now here in the Rockies, and knock on wood, we haven't had a lot of these issues.
Yeah, for sure. Well, that's perfect timing. It's just about a minute before half past the hour. I certainly appreciate it as always, Terry, and thank you for joining us and the questions for our town hall. And look forward to the next one. Everybody have a great day.
Thanks. Appreciate it.
Thanks. Take care. Bye.